I have a lot to say about libraries versus SaaS. I believe that a lot of the best open source companies that we'll look at over the next 10 years will be shipped as libraries and not as SaaS. And so some of the common ones would be like Betteroth, Autumn, and Rivet is a library first approach as opposed to a SaaS first approach.
Hello, welcome to devtools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited to have Nathan Flurry on with us. So Nathan is the co-founder of Rivet. I'm really excited about this episode because I've been trying to get Nathan on for a long time. I've been playing around with Rivet, I was playing around with ActorCore, which is an open source library that you're working on, which is now called RivetKit. And I can't wait to talk about that. But y'all have done a lot of great work, and I'm just excited to dig in more. But before we go talk about Rivet, would you like to tell our listeners a little bit more about yourself?
For sure. Yeah, I'm Nathan. Where do you start with these things? Go all the way back to where it's born now. I had a previous life building a lot of multiplayer video games. So at high school, I worked on a game called Crunker.io. If you're under 24 and you're a guy, you probably recognize it. If not, probably what is this cheesy little IO game? And through that process, I did a lot of work with infrastructure and real-time applications. And that's kind of what led into Rivet, which is what we're doing now for stateful real-time workloads.
Yeah. Was it you that your parents said no video games unless you built them?
Yeah, it was me. My dad is a software engineer in the 90s. He was an old school tech bro. It's sometimes you hear some of the stories and you're like, dang, nothing has changed. But he also did a media company called Media Station, late 90s, and sadly it went under during the dot-com bubble. But when I was 7, he was like, I'm going to start teaching. They wanted to expose us as kids to as many things as possible. So music, art, programming. And he was like, I'm going to teach my Nathan to program when I was 7. And so I started building games when I was really young, but I also started playing a lot of video games. And I think around 5th grade, they were like, this is a problem. So they banned video games in the household. There's no TV. There wasn't anything else. So what else you can do than build the games? And so I would hang out with friends as a kid, and we would just design and build video games for fun. And I didn't realize how weird that is in hindsight, but I really enjoyed it. And it was a really fun creative medium back in the day.
So did you and Nicholas, your co-founder, go to high school together?
We did. We went to middle school together. So we've known each other a really long time. We grew up in a town called Prescott. It's it's bigger now. They have an REI and more than one movie theater. But when we were a kid, it was what do you do? It's you go hang out at the Denny's, or you go to the one movie theater, see what's in town. And so we love video games. We love building things. And so we just kind of hung out and listened to bad techno music and build stuff for fun.
So when you were starting Rivet, when y'all applied to YC, the sort of theme was sort of infrastructure for games, for multiplayer games. That seemed to be sort of the pitch. It's we're gonna make it easy for game developers to build multiplayer experiences. But it seems now you've transitioned to more of a general purpose computing platform. Can you walk us through sort of what the transition from pitching YC to where you're at today?
Yeah, for sure. So coming off working on Crunker and a bunch of other .io games, I've had my fingers in most big .io games like df.io and a bunch of other mob.io and stuff like that in some way, shape, or form. And so through doing that, it was really easy to start a gaming infrastructure company because I was doing what I was effectively doing as a consultant, and now just transitioning that into a product of seeing the problems I've seen over and over again. And those problems in gaming are very straightforward. It's you need servers that are high performance, low latency, and don't get shut off randomly. And so that also requires things like UDP, which a lot of platforms surprisingly don't support. And the most important part is the elasticity. So if you have a surge of players, you need to make sure those players aren't getting turned away. Most games have downtime when they launch, which is their most important time. So that was our focus. And we were very focused on running Unity builds, dropping in a container, being able to scale up on the cloud, and being able to do it in your own cloud and stuff like that. Over time, we started getting more and more people asking for similar use cases outside of gaming. This idea of having a stateful compute is what we call it. So anything where you have a unit code that needs to be running to do something, such as a real-time, think about a real-time whiteboard. You need to have some unit code that is actually processing the logic for that. We got more and more clients kind of asking for that type of thing. And so eventually we started looking at where should we be focusing our effort? And I guess in parallel, we'd also spend a lot of time working at gaming services, and we had built a lot of technology on top of Redis. I don't know how deep you've gone into Redis, but we're writing these crazy like multi-thousand line Lua scripts and running it on a Redis instance to get like complex real-time logic on Redis. At that point, I had tried like an earlier version of durable objects, Cloudflare's durable objects, which seemed to be like a much more mature alternative to this. And I mean, it was crazy, just like migrating thousands of lines of Lua to like a couple hundred lines of code and being faster and getting edge support and all this other stuff out of the box. So it's kind of the combination of like being durable object build, if you will, and also having more and more people asking for something like durable objects, but open source and on-premise. That was kind of obvious to shift what we had built in gaming and actually make it more generalized for other applications. And so out of that came what's called Rivet Actors, which is built on the same like really high performance tech that we built for gaming, but for general applications.
So in that transition, did like the API just change completely, or were there still like the like smatterings of the current API back then?
Yeah, it was really funny doing the API migration because if you look in the cloud, you'd see like project, what we call namespaces, and then what we called actors. But like on the API under the hood, you would have games, and then you would like game namespaces, and then like there's all these like gaming specific terminology. And eventually we started adding aliases to like not make us you're calling like, why am I creating a game server? It's like, I don't know what a game server is. With our V2, we have like a clean API slate, and everything is called an actor under the hood. Yeah. But in terms of actual like support, like a lot of it there was a lot of overlap. One of the interesting components, which I'll go deep on some of the infra stuff. One of the interesting components is what we call Rivet Guard, is like this. It's effectively a mesh network that handles all the traffic routing through the Rivet backbone. So we try and abstract it from you completely. Like you don't know that there's any fancy networking going on under the hood. But when you run a container on Rivet, you need to have a bunch of extra things like DDoS mitigation. How do you handle things like container migrations? How do you handle like downtime of containers? How do you handle like surge traffic? There's a lot of other edge cases, like say you send a bunch of requests to a bunch of actors, you need to be able to spin up those actors in demand. But if those aren't running yet, then that request is going to fail. So Rivet Guard just acts as like this magic thing that runs behind the hood that was really important in gaming and is now also very important for what we're doing now.
Maybe it'd be a good time to take a step back and talk about what Rivet is building. So as I understand it, you have two main like compute products. You have container service. So it's like you're running like Docker containers or something similar. And then you have this like actor framework and actor service. So actor, like the Erlang actors, if folks are familiar with that, or like durable objects if people have heard about it. So can you kind of describe more of like what an actor is in this context and what it looks like in your product?
For sure. Yeah, I'm definitely getting into the weeds here a lot. High level, we call ourselves a stateful compute platform. What we consider stateful compute is anything that needs to be like long running or has real time or has like durable state. And so under that definition, you have something more like actors, which is, I'll get to that. And then like containers of just like a straight up like Docker container. The most basic concept of what we call an actor is like, hold on, let me run a bit. We're very focused on the idea of like actors, of like an actor basically has a start and a stop and it can go to sleep. And so, for example, if you're running an AI agent, the user will process a command or some event happens and the agent needs to take a step. It's going to wake up, process that step, sit and wait for some more commands for a bit, and then go to sleep. And during that process, you can actually do things like do a bunch of real-time connections, open WebSockets, publish messages to other things. A lot of really interesting logic. And if you extend that to containers, it's a lot of the same logic of like a container has a start and a stop and some form of persistence being the file system. So naturally, it all kind of fits together. And when you start gluing that together, it gets really interesting because you can start doing things like having your brains and your Rivet actor. So this is like what's going to be orchestrating all of the agentic logic, and then attach a container to do things like running arbitrary like Node.js processes or something like that, like secure things. And when you put those two together, it's a really interesting pattern that there's a lot of people building use cases around those technologies nowadays.
Okay, so you started in the gaming world and you're sort of like building this platform with containers and actors. Have your existing customers, if you still have like folks who are like building with you in the beginning, have they moved over? Are you seeing like people using the tools that you've built to like make games? And I'm just curious of like what sort of like use cases have come out of that and how that's pushed or your prioritization for what you build.
For sure. Yeah. We still have a lot of gaming customers. We can make sure that they're still able to be served by the current platform. But the use cases it's very similar. And I think it's it's really important to root how we build our technology. Like if it's not, we build everything we build to be fast enough for game. And so if it's fast enough for game, it's probably fast enough for everything else. And it's going to be probably be cheaper and way more efficient. And so everything down to like the way we do binary coding, the way we do like network traffic, the core is written entirely in Rust. All that stuff is very, very hyper optimized so that you can build a game. And I think that's especially in the world of JavaScript. Like I think it's good to have like really good core and then put the logic in JavaScript. And so I hope that as people try Rivet, they'll see that performance in practice.
Yeah, so my question is getting towards the Cloudflare of it all. In your guys' Y Combinator page, like your byline is open source Cloudflare workers and durable objects. That seems to be different than what we've talked about so far. We've talked about an actor framework. If I go through your homepage, I can see like you support many different backends. So like including durable objects. So like where does that come from? Are you guys re-implementing a lot of what those other services do so it works with all the services? Like, how does that shake out?
For sure. Yeah, we're very focused on like the Rivet actors or like an open source durable objects alternative to the point where like we think we built some really cool features that can actually run on top of durable objects that makes it's just, I mean, I've used durable objects so many times. I just know the things that you write over and over again. And so those features apply to durable objects, but also apply to all other platforms. But one really important thing that is especially in our Rivet V2 launch that we find really important is actually the flexibility of your infrastructure. When we launched our V1 back in January for Rivet actors, we kind of mirrored like the Cloudflare architecture of Rivet as a platform where you deploy your JavaScript code, and we have our own V8 isolate platform that runs your code inside of our stuff. And then we have all sorts of optimizations to scale up. The problem is that what you're asking people to do when you're doing that is to really bend over backwards to support your platform. Most people have everything in Kubernetes or their own cloud of choice like Railway or AWS or whatever, and private networking. And so it just becomes really difficult for people to adopt. And so the options are either like create like all sorts of security issues with running your code externally from your infrastructure, or try and run all Rivet internally on your infrastructure. So now Rivet V2 is actually a little more, it's much more lightweight if we don't actually run your code on top of Rivet. What we do is Rivet is a bit more, you can think of like more like Kafka, where it's a service that orchestrates everything that's connected to it, but you can connect what we call runners to Rivet from anywhere. So that lets us support platforms like Railway, like Kubernetes. We have Vercel coming very, very soon. I don't want to put a timeline on that just yet, and serverless platforms. And I mean, just like seeing the responses after V2 and the amount of people who are actually like tourists as opposed to like actually getting something real running just over the past week. We launched 8 days ago now. Is pretty impressive. And I'm really glad that we made this shift, even though it was like a lot of work on our end to rework it, but I'm happy that's happening.
Yeah, one of the things that you are working on that I like a lot is you call it the Rivet Inspector. So I've done a lot of things in like durable objects. And for people who are listening who might not be familiar with like a durable object, think of like a Lambda, AWS Lambda with state. It's like that, right? And your actor framework is the same thing. It's just like JavaScript functions and it has access to state. This all like really resonates with me because when I was doing the membrane startup, it was like this very similar sort of problem domain. But anyway, you have this Rivet Inspector, which allows you to like peek into the state of any of your actors in the network. And one of the things that can be hard about durable objects is if you've got a lot of them and they all have different state, is like understanding people. We had previous guests on talking about having a single database for every user that you have. And the problem with that is like, it gets hard to tell what's going on at scale and do migrations at scale and all that stuff. And durable objects and actors and all that can have those same sort of problems. So like good tooling visibility is important. I guess like a question for you is like, what sort of inspired that interface? And like, are there any other tools that you think you can build around this space to make it like even better?
The inspiration was, we talked to a lot of people who use durable objects. And I've never seen more internal dashboards, like crazy internal dashboards just for rebuilding the exact same thing. Everyone, like almost every serious use of durable objects has built an internal like JSON editor, JSON viewer of the state, and then like a couple buttons to trigger actions. And it's one thing to be like, oh, it'd be cool for an inspector. It's not only to see everyone rebuilding the exact same thing. So the Rivet Inspector is like, we call it like Chrome DevTools for Rivet actors. And so like you said, like it lets you inspect state. It lets you actually see the state updates in real time. So like it's a really fun demo to be able to like run an agent and then see the messages update in real time and see it thinking in real time in state, and then actually go back and like edit the context and then keep running the agent. It's pretty cool. But we also have a bunch of other things, like you can actually call what we call actions directly on it. So imagine we have like a little JavaScript console at the bottom where you can just run code inside of your actor. And I mean, in practice, it's really great for both debugging and in production. Kind of on your database per user point, I have a lot of thoughts on that. I think it's interesting to hear like the I don't think all databases should belong in durable objects. I don't think durable objects is like a one size fits all, and Rivet actors, of course. But I do think that in most large deployments, like you end up with something that looks a lot like durable objects in some way, shape, or form. That being, usually you're going to be running something like DynamoDB or Cassandra and in a large scale deployment. And what those do is they basically partition everything by partitioning key. So all data for like a chat will be in like a chat message key, or like a user's like shopping cart will be in a shopping cart key. And when you look at that, like that looks a lot like what a durable object is. And so I think when you talk about database per user, I think it's if you come from a background having used Cassandra or DynamoDB, I think it makes a lot more sense of like why most applications end up doing this in practice. And the cool thing that I really like about Rivet actors and by association durable objects is that compared to how you do it in Cassandra, where you have like just a single column or just a single table for each partition key, you can actually have a full SQLite database for every single one of those shards inside of durable objects and Rivet actors. And so that's really cool because now you can take like a chat actor and have like an infinite amount of chat actors that don't have any contention between each other, but have complex relationships within those actors with things like members and chat messages and stuff like that.
So in all the examples, I love your guys' homepage. It's like you just get out of the way. You're like, here's a bunch of code, figure it out. And one of those examples is like a chat room. But one thing that isn't all that clear to me is like, how does like data persistence happen? Reading through the docs a little bit, it seems like it's stored within the actor container, but could you expand upon that a little bit?
So when you're running Rivet, like in production, there are two components. There's your runner, which is like your JavaScript process that you deploy to AWS, to Kubernetes, to Railway, to wherever. And then the Rivet engine, which is like the core brains of Rivet. And the Rivet engine, we have a cloud version coming out very soon. But right now we also recommend self-hosting. Like we have a great one-click Railway deployment for the Rivet engine. When you deploy runner, the Rivet engine basically manages which runner is running your code. So there's a lot of edge cases you have to handle, like failover and what happens if the runner crashes, what happens in a split brain scenario. When you make a change to your actor state, there is like it does have to be persistent to a separate machine, similar to like database failover, for example. So there is like a mechanism internally for how we handle state updates to automatically persist. We also have special like ways of controlling how frequently is that persisted. If you're doing like a real-time game, you can actually tune that down to like debounce to like a max of like 1 second if that's what we want to do. And then like when you get to SQLite, we're SQLite is coming out very soon, but there's a lot of really fun tricks with the SQLite write-ahead log when you're doing this type of thing. So you don't have to like snapshot the whole SQLite database or anything like that.
One question I'd had about this, and a challenge that I've had on durable objects is, so let's say you have a durable object and it has a SQLite database as a backing store. It's got a schema. The SQLite database has a schema, and if you like deploy an update, a change to the code, you may have to run a migration on that. And in a durable object, they have just like this convention. There's this like place, I forget which hook it is, but there's this place where you can define your migration or whatever that needs to happen. And it's like weird because it's like all this like just logical code to control the migrations. But when you're thinking about like in actors, it's a stateful thing that's deployed somewhere. If you update the code that like relies on new state or different state, how do you handle migrations?
I'm sorry, can you repeat the last bit?
Yeah, how do you handle migrations with actors if you're like changing the schema of the state? I guess right now you don't have SQLite. You don't have SQLite yet. So
we do, but we've been quite a very SQLite support. We have SQLite. You can go in, install Rivet, get SQLite working. If you merge the right branches in the Rivet engine, you can get SQLite working. But it's when you're dealing with people's data, like this is not something you just ship like willy-nilly. Like, we're pretty careful about shipping SQLite when it's ready. So the way we have it internally is we feel funny talking about things that we haven't even released yet, but I'll talk about it because we've thought a lot about the problem. The implementation is not too different from durable objects. You do have like a migration hook, and we've gone all the way to provide first-party integrations for Drizzle migrations, and we've Prisma with their V7? Yeah, the V7 TypeScript only version coming soon. And those migrations are done lazily when an actor wakes up. So actors have like an important thing to understand about actors is they go to sleep when they're not in use. And so the cool thing is you're not paying for this like stateful compute when you're not using it, but it's pretty much automatic when it like starts and stops for you. Again, going back to like our magic networking layer is we can detect when you're about to make your network request to an actor and then start it and then send the request when the actor is awake. So in the context of a data migration, for example, if your actor is sleeping and you do a migration, next time it wakes up, it's going to do that migration. And we assume that the migration is going to be a pretty quick migration because your SQLite databases are not going to be like terabytes of data.
Nice.
You mentioned it a few minutes ago that there were some things in Cloudflare's durable objects that you felt could be improved. What are those things?
I want to be clear, like I very much love durable objects. I think that the team working on it is great. I talk a lot of crap on Twitter, but yeah, I think that there are a lot of patterns that I think Cloudflare and us see a lot of the same areas of improvement. Like they acquired the database team, so clearly the database team is working a lot on like front end stuff for the durable objects. I would be surprised if they didn't have a version of Rivet Inspector coming out soon. But on the more developer facing side, durable objects is like the core primitive. And so what Cloudflare did is Sunil built PartyKit because he had the foresight to see like, hey, we can take some of these like difficult sharp edges with durable objects and just like make it really easy to do just real time. And then, Cloudflare obviously saw that and was like, let's bring that into the core. Agents, same thing. It's like it effectively started as just a subclass of a durable object, and they called it an agent. But they've been adding some more and more features over the years to make it more agent specific. For us, we think that the primitive of like an actor needs a couple extra things to become more powerful. One of the most important ones is lifecycle management. With durable objects, it seems I don't know how it's implemented under the hood, so I don't want to put the words into anyone else's mouth. But it seems like durable objects they lean into the durability of it and kind of shut off your objects as needed. And so if you're building something like a game server or real time or a long running job, like it's not suitable for those use cases. I've recommended a durable objects to a friend to build a real time game a bit ago, and it's been a nightmare for him. And I kind of regret doing that. But with Rivet, on the other hand, like we care a lot about lifecycle. So the engine is responsible for a lot of complex logic with like how do you handle actor migrations, actor upgrades, of course, actor failover, and you can configure the engine to like leave your actor running until you are ready to actually like move it over. So kind of tying back to our roots in game servers is like we can't shut off game servers. That's a terrible idea. And so we take that so you can actually do things on durable objects like long running image conversions. Like you could hook it up to FFmpeg and do like a hour-long conversion. That's totally doable on Rivet actors. Same thing for game server, same thing for like background jobs. That's one. And along with that, you get some things like lifecycle hooks. Another one that I feel pretty strongly about is integrating durable objects takes a lot of context. You need to like really know how the Cloudflare worker platform works. So their platform requires you to have a fetch handler in the middle. So when you make a request, it goes to a fetch handler, and the fetch handler routes it to a durable object. With Rivet, that is still an option. A lot of companies, let's say, get more mature, go towards that. But when you're starting, usually you're like, I just want a Rivet actor, and I just want to talk straight to it. I don't need anything else in between. So we actually provide like React integrations. We provide like native client integrations. We even have a Rust integration that can work with like Python. And so you can just on your client say, get or create an actor, and then it'll give you an actor and you can talk to it. I'm going on some Amplifier, a couple other things that we like a lot. Another one, input state. You can pass the input state to your durable object or to your Rivet actor, and this extends to durable objects. There's no idea of a constructor in a durable object. We have full type safety on the API. I think they've been catching up on that, but all the way down to client, you have full type safety. Let's see, you can get your actor key within the Rivet actor. So durable objects, it's hard to know what your durable object is actually doing. You kind of have to like add all sorts of metadata in every single request. We have a metadata object that can see everything from your name, your key, your input, yes, I'm pulling a blank the last one. Let's see. Rivet itself lets you define which region your actors run in. So Rivet is a multi-region deployment. This is something I don't talk enough about. We have a really cool system for handling like multi-region scaling. And so you can actually say, hey, I need this actor to run over here. Cloudflare has a lot of limitations on that. Let's see. Connection persistence is another big one. So on the topic of failover, most people don't handle WebSocket disconnects and stuff like that correctly on durable objects. We handle that for you. So if you open a WebSocket from the client, your actor could upgrade, it could migrate, and the WebSocket could be uninterrupted. I'll leave it there. But there's a lot of small things like that that we include in the core primitive that I think are important for 90% of use cases.
Yeah, the WebSocket
last
thing in
one.
particular. Oh, please.
Yeah, the last one is events. We have a native concept of events. And so you can actually do real time is dead simple in Rivet. And that also means that we also provide an abstraction over WebSockets, service end events, and HTTP to just choose the right protocol for you. I'll quit.
Yeah, no, that's awesome. I was going to say one of the things in durable objects that can be hard is just like handling WebSockets in general. But there's a really subtle case is, so they have this special WebSocket handler where it safely allows the durable object to go to sleep. And if you don't use it or use it incorrectly, it can keep your durable object open for a long time, which actually gets very expensive very fast. So it's like a good way to get a surprise bill if you're not architecting it correctly, which is unfortunate.
That's the point you're making is another really interesting one. That's something I think Cloudflare has done very well, but they're also very quiet about, is the fact that Cloudflare is not cheap at all. They're really, really good about making it seem cheap to the user. Like the value you get out of the platform is much, much higher than what the actual compute costs. But if you go run the numbers and compare it to VPS, their margins are nuts. And I more power to them. But it's interesting to see the disconnect between the actual price of what you're paying versus the price you're paying versus the value you get out of it. Because to your point, if you leave a durable object on and it doesn't go to sleep, then it's actually really expensive. You might as well be paying for a VM at that point.
I'm doing one off the cuff. So when I look at this API, I see state, I see actions. Ever since our episode with XState, I see XState everywhere, and XState in the cloud seems like a really cool proposition. So have you guys tested the waters with that? Done some tech demos of what would a state machine be here? Because it looks like you're like 2/5 of the way to state machine.
Yeah, we have a lot of ideas. I have a linear project where I just dump ideas. I've got a great key binding, just press C, send an idea, and it's so many. There are a couple of integrations that I really want to do, but our focus has been primarily let's get self-hosting in the open source the best experience possible. And I really like what we did it with version 2. It's literally a Docker run, or you download a binary, and then you just say, here's what the engine runs, and it just works now. So now we're actually able to start tackling some of the fun stuff. So to list off a few that I'm really excited about, LiveStore, number one, for local first sync with Rivet actors is a really great use case. The second one being effect workflows. I think that makes a lot of sense for actors, to your point, because tying it back to the stateful compute, it's an effect workflow can be running for a long time, but you also need the durability in case your machine crashes. XState, I haven't messed around with as much, but I've looked at it a couple times, and it seems like there's a lot of overlap in terms of that type of thing. Yeah, let's see other integrations off the top of my head. I'm trying to remember. Of course, BetterAuth, we have a BetterAuth integration, and we have a better one coming soon. I'm pulling a blank on there's so many cool ideas. I have local first, durable workflows, and real-time stuff. I even thought about adding socket IO support just for fun.
Yeah, you certainly aren't lacking for integrations. Even though you guys don't have all that many, you still have quite a lot. You list every major JavaScript thing I know about it.
It's because I see Rivet actors as an undervalued primitive in the TypeScript ecosystem. If you go to Java, if you go to C#, go to Elixir, they all have their own versions of what Rivet actors are. So in C#, they have the Orleans framework, and specifically virtual actors is the closest one-for-one comparison. Akka in Java, and of course Elixir and OTP. And I think it's interesting that this hasn't caught on in JavaScript at all. And I want to asterisk that because I think JavaScript developers I think everyone has to thank JavaScript developers for being willing to try a lot of new ideas and being able to innovate and everything. But it's interesting that the actor pattern just never really made its way into JavaScript until durable objects really popularized the idea. Yeah, and so I think the reason that we're so focused on so many integrations is because I don't want to say I don't think every application needs that Rivet actors, but I think it is definitely a primitive that replaces a huge swath of complexity in most applications. Most applications are trying to rebuild what Rivet actors make simple with event sourcing with Kafka, trying to use temporal, which is ungodly difficult to use. Real-time stuff, you're setting up pub sub servers and all sorts of like crazy persistence mechanisms, all the stuff that Redis is trying to ship. Like it becomes dead simple in Rivet. And so I think that there's a lot of opportunities for us to work with these other tools.
I want to talk a little bit about your strategy here. Y'all have this like saying that you think that libraries are the future and open source SaaS is like dead in the water. And I'm curious about expanding on that philosophy, but also it's like the core of your product is you build it as we're going to take like a durable objects like primitive, make that open source, make it self-hostable. But of course, you're also like a YC-backed company and you need to be very financially successful. So I'd love to hear like how you think that whole thing plays together. It's just like, what is the future where like people just choose open source libraries and also we can build sustainable software companies?
Yeah, libraries is an interesting topic. As you know, I have a lot to say about libraries versus SaaS. I believe that a lot of the best like open source companies that we'll look at over the next 10 years will be shipped as libraries and not as SaaS. And so some of the common ones would be like BetterAuth, Autumn, and RivetKit is a library first approach as opposed to a SaaS first approach. So when I say library first, what I mean is step 1, npm install, step 2, import, step 3, it works. As opposed to almost every other open source SaaS nowadays is you sign up for their service or you download a binary, you write a config file, then you connect your application, and then you get it working. And once you get it working, it's great, but the integration time goes up and running it also becomes more difficult. And just the development environment, you end up ending with like Kubernetes setups just to run some open source tool, whatever. The two reasons that I think libraries are going to win over the next couple of years is one, the most important one is that agents are picking libraries now instead of humans. And so instead of Googling like durable workflow engine and then seeing temporal has like all the best SEO right now and then picking temporal, you're going to be going into Codex or Cloud Code and being like, my billing pipeline is failing, please fix. And then the Cloud Code is going to go be like, oh, it's crashing mid request, so we need to go add a durable workflow engine. And Cloud Code, when it's the agents are incentivized to get the fastest working solution as fast as possible. And agents can't sign up for SaaS services. And it's really difficult for them to like orchestrate setting, installing a binary in the background, yada, yada, yada. It's going to opt for the simple npm install and then get the whole thing working right off the bat. And so agents is a big reason why I think that libraries will work in the long run. BetterAuth, I think, is also probably seeing a similar thing already. There's a ton of code on GitHub for BetterAuth already, and it's probably making its way into training models. But when I say at auth, like it's probably going to offer BetterAuth instead of telling you to sign up for other services. The second reason is just that I think a lot of developers prefer simplicity in the application. I think that developers are wary of complexity and adding more and more like critical components to their applications. And so when you install a library, there's something about that where just there's less complexity and less moving parts. Tying that to like revenue and actual like deployment scaling, we do have the Rivet engine, which is effectively like it takes the library component and then it kind of supercharges it. So you can run Rivet kit without any external services on a single node. But like once you're like, I am reaching a certain scale and I need to like really go crazy, then you can pull in the Rivet engine and that's going to be like a drop in a one line endpoint for where to connect to the engine. And then you're going to be able to scale horizontally. And so as a company, our bet is that people will build more and more with Rivet actors. And as you invest more into it, then there are certain enterprise use cases that a lot of people don't need. And so we're technically an open core company if you were to get into technicalities. As in, we feel strongly that our core should be Apache 2, so permissively licensed, and be usable for like a huge amount of use cases. But we can make money off more traditional enterprise deployments, things like Databricks, for example, or like comparable to Databricks with Spark, for example. And with our cloud, we can provide a managed solution for people to run without having to self-host. But I strongly I like this company a lot because I think it's a company where we can have a very strong open core and a strong open source philosophy and a strong investment in libraries, as opposed to trying to kind of walk a fine line of doing things like licensing AGPL and then like not really being open source, but calling yourselves open source or following a HashiCorp. And I hope I don't bite my words in a couple of years, but I'm fairly certain that like this is actually going to work. If you look at companies, there's a lot of companies I can list who have made this work. We're a lot quieter than the people that people point fingers at.
That was my next question. Do you have any like examples of companies that you would put into this category? Like I was trying to think through it and like Vercel is one. Like they provide Next.js. It's a free open source thing that anybody can run. Then they supercharge it on their platform just like they would on Rivet's cloud.
Oh, for sure. Yeah. No, Vercel, I think, is the number one example of like a library that really worked, and then taking their more advanced thing to like supercharge it, like you said. They've had some controversies, of course, but I think that they've dealt with it pretty well. We actually used to say like the first version of ActorCore, which is our library version of Rivet, was effectively, it was Next.js for something. I don't remember what he said, but it was like Next.js for something. So it's like exactly what you said is right on the money.
We've talked a lot about like features of actors and what Rivet provides, but given your current users and like what you want to see people using for, if you had to just talk to the developers listening to this, what would you say would be the single best reason why they should try Rivet?
To be incredibly simple to answer, I would just say simplicity. It's something that I think if you have touched Kafka or touched a lot of like PubSub or real-time tools, and you try Rivet, you just give it like 5 minutes, you'll immediately understand why things are so much simpler with actor pattern and why other industries have adopted this so widely. You know, why WhatsApp was able to sell $1 billion company with 35 engineers because of the actor pattern. Some of the most core use cases, which I think will benefit from this, are of course agents, very timely for AI in terms of managing state, managing complex actions and long-running tasks. Other ones being real-time. So real-time is just like built into the core of Rivet itself. And then anything with like durable or long-running tasks. So if you're touching like Redis, Kafka, or Nats, there's a good chance that Rivet will probably significantly simplify your application.
Yeah, it seems like when you start from a JavaScript point of view, you have a much different view of developer experience. Like when I try to go outside the JavaScript ecosystem and I'm reading like docs and setup guides, it's like a whole different ball game. Then I go back to JavaScript and they're holding my hand the entire way. I'm like, oh, okay, this all makes sense now.
Yeah, I spent a lot of time writing actually iOS apps. Like I was like a 3-time WWDC scholar. Some people will know what I mean by that, other people won't. But I think that's like I think there are two things that a lot of great engineers can do. Is one, like start by building games, because you're going to learn about performance and like what low level actually means and like how low can you take your code. And the second one being build with the iOS ecosystem. Not because you ship iOS apps, but Apple has put so much care into their developer tooling that like both on like the actual developer experience side you just talked about, and also that as an engineer, you're basically forced to read their human interface guidelines, which is their design language. And so even if you're just like the worst iOS engineer is probably considered a pretty decent design engineer by like most other standards. And I think that like having built Rivet and doing a lot of developer facing tooling with Rivet Inspector and then like building like the developer experience, it's very like egotistical to say this, but I think that a lot of that has transferred over. And I think, yeah, it seems to be showing. So
yeah, I think an interesting point here, this is just like some broad conjecture. You were talking earlier about how like actors haven't really called on in the JavaScript space. And there are a lot of programming ecosystems, like any language that runs on the Beam, like Erlang or Elixir or Gleam or whatever. They have access to this OTP, this like native actor framework there. And every other like ecosystem, it's pretty much, it's a service. It's a thing that you have to run. And classically, like historically, the JavaScript ecosystem has been like shying away from running its own infrastructure. Although I think that's like really changing a lot as we see the sort of fatigue of all of these services these hosted services trying to bite out every little part of your application. And now you can't like build anything without signing into 5 different dashboards for whatever. So I don't know. I think it's very timely. And also we just haven't seen other people handle this well, especially not in a way that can be self-hosted. So I'm excited about what you're all building. And I think, I don't know. I think this is the right moment for it too.
Appreciate it. Yeah. Helping spread the word of actors. Actor pilling everyone.
Yeah. Cool. As we get close to wrapping up here, we always like to ask our guests a future-facing question. And I've got a few here, and I'm trying to figure out which best one would be to ask you. So what do you think, like, when you think about, like, the infrastructure today and how we build apps, and then the infrastructure that you want to introduce with Rivet, what do you think will need to happen to make a shift to be closer to the world that you want to see? And what do you think that, like, y'all are going to do to help win that market? Like, what does that look like for you?
Let's see. So the first part being like, what do I think needs to happen to see the shift close to the world I want to see? So I feel like I should start by defining the world I want to see. In my opinion, like the concept of actors, this like 30 to 40-year-old concept, simplifies a lot of things. I mean, like you're simplifying away a lot of like your pubs up infrastructure, a lot of your Kafka, your durable compute, your like crazy database complex transactions into like just using an actor. Just have one 15-line script that you write that just implements all your complex logic as a script. I think the world I want to see is like actors is the default thing that you reach to if you need something that will do any sort of like complex logic beyond just a stateless web request. And so again, like Kafka pops up real time. And I think the way that we get there is right now we're focusing on just like really, really painful infrastructure, being agents in real time. Like things where you see a post every couple of days in Hacker News of like, we rewrote everything on our agent infrastructure from scratch because of X, Y, and Z. And the only people not suffering from this are people building undurable objects until they need to go on-prem. Then we talk to a lot of those people, but that's a different story. So the way I see that getting there is like, start with the pain points of the things that like actors really, really help solve. And then I think enough people will start realizing, understand the core primitive that's available to them. And then as they start using more and more, building more and more things, it's kind of like actors become the first thing that they consider to try and build with. And then realize that, oh, wow, at the end of the day, my application is significantly more simple. Like one of the most common, we had a customer, for example, that was doing something like this, where like they were starting with just basic, I think it was just like a basic agent, but then they started realizing they need like some sort of background job. And so then they realized like, oh, actors can go to sleep but wake up on an alarm. And so now they start using actors for like a separate background jobs with schedules. And then, as you can imagine, like extrapolating is like, okay, now I need to add like image conversion with FFmpeg. Like that's a drop into Rivet. And I assume that I would be surprised if someone didn't ship like an FFmpeg like library for Rivet at some point, because it just runs anywhere. Yeah. So start with the pain points. People understand the primitive and then realize like how flexible it is for their future use cases.
Sweet. That wraps it up for our questions this week. Thanks for coming on, Nathan. This was a really interesting dive into the thing that you've built. It's come a long way and it seems like a very useful tool. I'll definitely be giving it a try the next time I need something that does that. So thanks for coming on and talking about it.
Awesome. Thanks a lot. I'm glad we finally made this happen.
Yeah, I'm super excited we made it happen. I'm a big Rivet fan. So yeah, excited to see which our build. Continue to build. I'm excited for SQLite support. And yeah, I can't wait to see what y'all do next.
Awesome. Appreciate it.